All right, so let's look at question 1 of this tutorial sheet. This tutorial sheet 9 for October. So question 1 is saying you throw a ball with a mass of 0.40 kilograms against a brick wall. It hits the wall moving horizontally to the left at 30 meters per second and rebounds horizontally to the right at 20 meters per second. Question A, find the impulse of the net force on the ball during the collision with the wall. B, if the ball is in contact with the wall for 0.010 seconds, find the average horizontal force that the wall exerts on the ball 1 during impact. Okay, so we've been given a diagram for the whole scenario. So you throw, or the top part here is indicating the time you are throwing your ball for mass 0.4 kilograms to the left. So since this is dealing with momentum or forces or velocity, we know so velocity is a vector. So since velocity is a vector, in this case we have to indicate the directions clearly. Since it's bouncing off a wall and going back again, that means we have to indicate the direction of your velocity. We know so velocity is a vector, and that's why on the top part here, since it was going towards the negative direction of the x-axis, it was represented as a negative 30. You can see here, there is negative 30 meters per second. Whilst when it bounced bounced off the wall, going back towards the right or the positive x-axis, it was, or the velocity now changes to, or changes direction to 20 meters per second. So the first question is saying, let's calculate the impulse of the net force on the ball during its collision with the wall. So let's go to my board here. So we've been given some data. We know to say mass. Mass is equal to 0.4 kilograms, like that. Then we've also been given u, which is the initial velocity of negative 30 meters per second. We have the final velocity of 20 meters per second, like that. And we've been asked to say we should calculate the impulse for the net force after collision with the wall. So what is the definition of impulse? We know to say impulse is just actually the change in momentum. We can represent it using this formula. P is equal to what? It is equal to delta change in momentum. And momentum, the formula for momentum is just actually mv. So if this is the change in momentum, that means we have final momentum, P final, minus P initial. Final momentum minus initial momentum. That is going to give us what we call impulse. I'm sure that's very clear. So from there, what are we going to say? We're going to say our impulse is equal to what? It is equal to, since the mass of this, or since the mass of the ball is not changing, we can actually simplify this formula. This is equal to mv. We're going to say m. We're going to factorize it. M is equal to what? Or m, open brackets, and I'll put my v final minus u, which is the initial velocity. So that is also giving us the same thing, which is the change in momentum. So what are we going to do? We'll say this will be equal to what? So remember, this is impulse. Sometimes it can be represented as J. There's no difference there. Okay, so I is equal to what? Is equal to m. What is the value of m? M is 0.4. 0.40. Then we have the final velocity. What is the final velocity? We know to say the final velocity is 20 minus, what are we subtracting? We're subtracting the initial velocity, which is negative 30. Remember, we have to include the direction of our velocity like that. You don't Shouldn't ignore it. Okay, so this is going to give us what? It's going to give us 0.40 multiplied by 20 plus 30. Here we have the negative and the negative. These guys can actually multiply to give us a positive value. So we have 0.4 outside there with a 20 plus 30 inside our brackets. Then what can we do? We can add the ones that are inside, which are in the brackets, which is 0.4, multiplied by what is inside the brackets, which is giving us a 50. Okay, and this is going to be equal to what? This is going to give us a final answer, which is 20. And impulse, remember, impulse is a force, so the SI unit is going to be in newtons, which means the impulse that was produced during the collision was equal to 20 newtons, like that. Okay, so that was question A. What about question B? So on question B, we're going to say we're supposed to find the average horizontal force. So how do we define, or how do we identify our average force? What is the formula for calculating our average force? So I'm going to say F average, include the AV there, being equal to impulse, of which here I'll represent it with a J, over the change in time. So this is the time taken during the collision. If the two bodies are colliding with each other, the change in T, the delta T that I've included down there as a denominator, is just showing us to say it is the time that the two objects were in contact with each other. So average force there, it is given by the impulse over the time of collision, or contact time there. So we've already calculated the impulse. We've said it's 20. So my average force here will be equal to what? It will be equal to 20 newtons over. They already gave us the time of contact, and they've told us to say it was 0.01 seconds, like that. And our final average force will be equal to what? It will be equal to a value which is equal to 2,000 newtons. So remember, this is a force, so it will just exist as a Newton force, like that. Okay, so that was question 1. It only had parts A and B, and that's all. Kindly like, share, and subscribe to the channel for more of such content. Thank you.